In this video, we'll be going over exponent problems where we have to raise a power to a power, and problems when we have the same exponent. So before we get started, let's go over a definition of exponents. We know that exponents represents repeated multiplication. And in this example here, when I have 3 to the 5th power, this 5 is telling me that I have 5 of these terms being multiplied together, and the base 3 is telling me that what's being multiplied are all of these 3's. So 3 to the 5th power is going to be 3 times 3 times 3 times 3 times 3. And using this definition can help us solve the next problems. So here's example 1. Here I want to simplify this expression. Remember that when we simplify an expression, we want to write it with a single base and a single exponent. So here we have 3 to the 5th power, which we figured out on the last slide. But what happens when we take 3 to the 5th power and raise it by another second power? So to figure this out, the first thing I'm going to do is I'm going to ignore what's on the inside here. Right? Now let's just talk about what does it mean to have something raised to the second power. Something to the second power means I have 2 objects being multiplied together. What's being multiplied together? So taking a look on the inside, I see that I have 3 to the 5th inside each of these parentheses. So inside each of these parentheses, I have 5 of these 3's being multiplied together. So 1, 2, 3, 4, 5. And then I have another 5 of these being multiplied together. Now that we just have a bunch of 3's being multiplied, we can simplify this with a single base and a single exponent. I know that since all of these are 3's, the base is 3. But what exponent can I use to represent all of these multiplications? Since I have 5 of them over here, and another 5 over here, in total I have 10 3's being multiplied together. So this is going to be 3 to the 10th. Let's go over our next example. Here I have 5 to the 2nd power. But what happens when I try to raise this to another 3rd power? Just like before, I'm going to ignore what's on the inside. And let's just talk about what does it mean to have something to the 3rd power. Something to the 3rd power means I have 3 objects being multiplied together. What's being multiplied together? Well, inside each of these parentheses needs to be 5 to the 2nd. So I have 2 of these 5's being multiplied together. So I have 5 times 5, another 5 times 5, and another 5 times 5. Now, counting everything up, I know that my base is going to be 5. What exponent can I use to represent all of these 5's being multiplied together? So, since I have 2 over here, 2 here, and 2 here, that's going to be 5 to the 6th. Let's go over our third example. Here, I have 2 to the 100th power raised to another 4th power. Just like before, let's ignore what's on the inside. Now, let's take a look at that outside parentheses. Right? This exponent on the outside. What does it mean to have something raised to the 4th power? It means to have 4 of these objects all being multiplied together. What's being multiplied together? Taking a look on the inside, I have 100 of these 2's. I kind of don't want to write all these out, so can we just imagine in our head that inside each of these parentheses, I have 100 of these 2's. Here I have another 100, another 100, and another 100. So, again, imagining all these 2's being multiplied together, how many 2's do we have in total? Since I have 100 2's here, another 100, another 100, another 100, counting them all up, I have a total of 400 2's all being multiplied together. Now let's go over some problems where we have different bases but the same exponent. So here I have 2 to the 3rd times 5 to the 3rd. Again, notice how they have different bases but the same exponent. So just using our basic definition, I know that 2 to the 3rd power, that's going to be 2 times 2 times 2 for a total of 3 times. Right? Taking a look at the 5 to the 3rd power, that's going to be 3 of these 5's all being multiplied together. So how can I write this with a single base and a single exponent? Again, notice how we have 2 different bases right now. We have 2's and we have 5's. Well, one trick that we can use is I can take one of these 2's and multiply them with a 5 using the commutative property. So 2 times 5, that's going to be 10. Another 2 times 5, that's going to be 10. And another 2 times 5 is going to be 10. Notice how after multiplying all these 2's with all those 5's, now we have a single base. So I can write this with a base 10, And what should my exponent be? How many of these 10s do we have in total being multiplied? Since we have 3 of them, this is going to be 10 to the third power. All right, let's go over our next example. Here I have 3 to the second times 6 to the second. Again, we have the same exponent, but different bases. So, using our definition of exponents, 3 to the second power, that's going to be 2 of these 3's being multiplied together. All right, 6 to the second power, that's going to be 2 of these 6's being multiplied together. Now, how can we write this with a single base? Again, just like before, I can take each of these 3's and multiply with each of these 6's. So, 3 times 6, that's going to be 18. Another 3 times 6, that's going to be another 18. So, how can I write this with a single base and a single power? How many 18's are we multiplying together? Since there are 2 of these 18's, this is going to be 18 to the second power. Finally, let's go over our last example. Here I have 7 to the 20th power times 5 to the 20th power. All right, using our definition, 7 to the 20th power. Again, to the 20th power is a pretty large exponent. I don't want to write all these 7's out, but can you guys imagine in your head? Imagine that I have 20 of these 7's all being multiplied together. Okay. Now, using the next term, 5 to the 20th power, can you guys imagine? I have all of these 5's, 20 of them, all being multiplied together. And just like before, I can multiply each of these 7's with each of these 5's. So 7 times 5, that's going to be 35. 7 times 5 is going to be another 35. And so I know there are 20 of each of these 7's is going to have a match with each of these 5's. So I know my base is going to be 35. What should my exponent be? After multiplying all these out, how many 35's are we going to have? Well, since I know there are 20 of them and they all have a match, this is going to be 35 to the 20th power. So in conclusion, when I want to raise a power to another power, what I'm doing is I'm taking these two exponents and I'm multiplying them together. And when I multiply two exponents with different bases and the same exponent, what I'm really doing is I'm just multiplying the two bases together.